Hi dear students, welcome back to computer science class. We have in our previous session we have seen basic aspects of stack, like what a stack is. Actually, what is a stack? Stack is simply a data structure which is used for storing, retrieving and organizing data in an efficient manner that gives what optimal performance, right? And stack is a linear data structure, and we implemented the concept through list. We know list is also a sequential data structure at the same time as well as what stack is also a dynamic data structure as well as linear data structure. What do you mean by dynamic? The size can be increased or decreased at any time, right? That is what dynamic is. And plus we implement, as I've told you, we implement stack in terms of list, so it supports heterogeneous elements as well. Yeah. So what is a stack? Stack is a linear data structure in which insertion deletion performed at one and called top of the stack, and insertion is called push, deletion is called pop, and information processing is what last in first out. Last inputted item can be taken on first. Example: pile of books, pile of trays, stack of coins. Then computer based applications, undo operation, browse the internet, right, are some of the operations. Then now we are heading to the implementation of stack using list. Implementation of stack using list. We have seen what a stack is, right? Then now we are going to implement the concept. Implement the concept of stack through some of the operations. And here is a list of operations. Basic operations: creating a stack, push or insertion operation, check for empty stack, pop or deletion operation, and traversal or display operation. Okay, these are the basic operations. Creating a stack, inserting element into a stack, that means push operation, or we can say about adding element into a stack. Check for empty stack, checking for empty stack. Pop or deletion from a stack, meaning deletion of elements from a stack. And finally traversal or displaying elements from a stack. Okay, and we can look at creating a stack first. How can you create a stack? We know stack is only a concept. Stack and queue are only concepts, and we are implementing these two concepts through list, right? Yes. So creating a list stack. We create a stack as a list. We are creating the stack as a list. So how to create a list? We know, we have already learned how to create a list. We have one function list, or you can directly with the help of stack equal to something, with the help of square brackets you can create a stack list, right? Okay, here also we are following the same method. We have a method list, okay, function or method. Then create list. Actually at the time of after creating a list, what happens? The address can hold all the elements or all the positions, right? It will create an address in the computer memory which can be used to refer to each location. Any number of heterogeneous elements can be stored, right? We know list is a dynamic data structure, so we can store any number of heterogeneous elements. Yeah. Then here the syntax: stack equal to list, or stack equal to square brackets. And both these, stack equal to list function, stack equal to square brackets, both creates an empty stack. Because can you see any element here? No. Okay, both these statements create empty stack. Okay, then stack, here stack is of list type, which will stack is a variable which is of what type? List type, right? Okay, then how can you refer to each element? Using stack of 0, stack of 1, stack of 2. Okay, yes. So here this way we can create a stack, or create a stack as a list. Okay, we are creating stack as a list because stack is the only concept. We implement it through the list. So we have two methods to create a list. One is using list method, another one is a normal method. Okay, so either of the method can be used for creating a list. Then which create an empty stack. Okay, yes, here stack is an empty stack. Then here stack is simply a list. Okay, then through the operation we are making it as a stack. Yeah. Then stack list type 1. Yeah. Then stack of 0, stack of 1, stack of 2 are the elements. Okay, yes. Then adding elements. Adding elements into a stack, it's called pushing, or inserting element into a stack, it's called push operation. And we have a function, we have a list function, list method called append. Append function is used to insert or add element into a stack. Okay, yes. Syntax: list.append x. Here x is element to be added. X is the element to be added. onto the stack. Okay, yes. Here is the algorithm. You know what algorithm is? Step-by-step instructions written in English to solve a problem, which gives set of procedures to solve a problem. Here the problem is push operation. Okay, yes. So initially we'll have start and finally end. Okay, yeah. Then start, we are starting with start, then initialize top with -1. We initialize top with -1. You know why we are setting it with -1? Because suppose, okay, you know the indices 0, 1, 2, 3. Okay, suppose at present we have an element, the first only one element there in the stack, which is at 0. Okay, for the next insertion, for the next push operation, you have to increment the value of index to 1. How can you make 0 to 1? It's by incrementing 1, right? Then now we have two elements, okay, at 0 and 1, and we are going to insert a 2, the index 2, and at present top points to 1, right? Then how can you make it to 2? 1 plus 1 equal to 2, so you'll have to increment. So in each push operation you'll have to increment the value of top by 1. So initially when the stack is empty, we know top points to nowhere, right? If top points to 0 means there is an element, there is only one element in the stack. So when you create, just after creating a stack as a list, there won't be any element at the time top must points to -1. Okay, so -1 plus 1 is what 0 is. When you have one element, it will be at 0, and -1 plus 1 is what 0 is. Okay, yes, hope you get it. Yeah. Then element equal to input, enter the value. You can enter the value which will be stored at element. Then we are applying stack dot append. Here is the function append. Stack dot append element. Element can be passed to the function, okay, which will be added to the stack. Then end. You know how this function works? Yeah. Initially start, then initialize top with -1. Then element equal to input. We are storing the element in element. Stack dot append element. Element will be appended or added to the stack. Okay. Finally end. Yes. So element will be placed at the top or top plus 1 position. Okay. We have seen the example in our last program. Okay. So this is how adding elements work. Okay. Yes. The first one is creating stack. Can be created using stack list function or a normal method. Then here using append method. Okay. Yes. Next operation is check for empty stack. Okay. Our third operation is checking for empty stack. Checking for empty stack. When do we need checking for empty stack? This operation at the time of, mainly at the time of deletion of an element. Okay. Just before deleting an element, we have to check whether the elements are present or not. At least one element is present or not, and it's checked using function. Okay. Yeah. So this method. Okay. We have 3 different algorithms for performing checking for empty stack. Okay. Yes. So checking for empty stack, before delete or display operation, we are performing this algorithm. Here is the first algorithm. Start stlen equal to len of stack. Len of stack. What is len of stack? We know len is a function that returns the length of an item. Here it is stack. So length of the list, meaning total number of elements in the list, will be what? Returned to stlen variable. Okay. Len function finds the length of the stack and returns to stlen. Then if stlen equal to what? Square brackets. Simply we don't have any element, right? It is empty. It is empty. Empty square brackets. Yeah. Print empty stack. Code step 5. 5 is end. Otherwise, if it is not satisfied, what? If stlen equal to what? Not empty. What happens? Element equal to stack dot pop. We know pop is a function used to pop or delete element from a stack. Okay. It's an inbuilt function, built-in function for performing deletion operation or pop operation. Yeah. End. So here is the first algorithm, and we have another one, alternative. Okay, another algorithm. We are following the same step. What? Start, then stlen equal to len of stack. Then if not stack, what happens? Print empty stack. Go to step 5. 4th and 5th are the same steps. Okay. What else? What happens? Element equal to stack dot pop. End. Okay. It means if not stack in the sense if there is no element in the stack, right? Not is an operator. If not stack means stack having 0. If stack is having element it won't be entered into the loop or into the condition. Okay, it will be moved to fourth step. If not stack means if not true, right? If not true, not true in the sense 0. Yes, so at the time, okay. And we have one more one. Okay, second step is if not ln of stack, just like about if not stack. If not stack or if not ln of stack, both the same. Okay, if not stack means if not what 1, meaning 0. Here if not ln of stack, there is no length. There is no length means 0 length. That means 0. Okay, if not ln of stack, it won't be positive. It won't be positive. Yeah. Meaning 0. Okay, empty stack. Good step for first step is end step. Okay, end. Yeah. So these are the different algorithms for checking for empty stack. We are mainly checking for empty stack in the case of deletion as well as display operation. Okay, the first one is we are finding the length and assigning the length to STLN. Then STLN equal to what, square brackets, empty. It will be empty. Then if not stack, it will be empty. If not ln of stack, if not stack, if not ln of stack, both are somewhat same. Okay, yes, it will be empty stack. Okay, and the fourth operation is deleting an element. We know deleting an element is called pop operation, and we have two formats. List.pop. We know pop is a function. We have already applied the function here. Okay, pop is a method or a function which is a built-in function just for popping the element, deleting the element. So here is a syntax, list.pop or list.pop of I. Here I is not mandatory, I is optional. Why? Why I is optional? Because here we don't have the privilege to delete any item we wish. Okay, we can insert what we can delete only the topmost. So there is no scope for I. There is no space for I. Okay, I is optional. Yeah. So which returns a popped element. Okay, which returns a popped element as well. Yeah. So using pop function, we can pop an element from the stack. There is no privilege to pop or remove or delete any item. Okay, we can delete only the topmost element from the stack. Okay, yes. And finally, we have traversal, traversing or displaying operation. What is a traversal or display? After push or pop operation, we have to traverse just for knowing the status, checking the status of the stack. That is just after inserting. At present we have 3 elements. After inserting one more element, there will be 4 elements. Okay, we have to display it out. So traversal is used to display, or what we perform traversal operation just after push or pop operation, just for knowing the status of the stack. Right? How after deleting one item, suppose we have 3 items. After deleting one item, we'll have 2 items. Okay, we'll have to just show it off or display to the user. Okay. It's working properly or not. Okay, so these are the different operations that can be performed on a stack. Okay, first we have seen creating a stack, creating an empty stack. We know stack is only a concept. We are implementing through list, right? So we are creating stack as a list. Okay, yes. So using the function or method list, we can create a stack or stack as a list, or simply using square brackets. Okay, we can create it. And the second operation, inserting that item into a list, it's called push operation, or adding element. Okay, we are making use of append function. Okay, list.append of x will be added to the top of the stack. Okay, and the third one, checking for empty stack, we have ln of stack. Then if STLN equal to square brackets, or if not, it's not stack, or if not ln of stack. Okay, we can make use of any of this algorithm to check for empty stack. And we perform checking for empty stack just to delete or display item. Okay, and the fourth one is deleting an element using pop function and pop of I. I is of course optional, because we cannot decide which element to be deleted. Okay, only the topmost element can be deleted or popped from the stack. Then traversal or display. After performing push or pop operation, we have to see the status of the stack, right? So just for that purpose, we are performing traversal or display operation. Okay, yeah. So this is all for the time being. You just go through all these topics, and in the coming class, we can have the implementation. Okay, we can have the real practical session for all these topics. So you just go through all these topics thoroughly. Okay, so this is all for the time being. Thank you for watching. Have a nice day. See you in the next video.